Hello, welcome to What's Your Question? In today's video we're going to be answering the question, what is a force and what does it do? Let's go! I've placed the three objectives of the video right here, and they're to state the different forces and examples of those different forces. We're going to describe how forces can affect objects, and we'll explain how we can calculate moment. To start with then, there are a total of 5 different forces that you need to be aware of. The first of these forces is friction. Friction involves two objects rubbing together. If one object is rubbing in one direction, say my hand moving that way, friction will oppose the direction of its movement. So if I'm pushing this way, friction is pushing back against my hand to oppose its forward force. The second of these is air resistance. Air resistance is caused as you're trying to move through the air because the particles collide with you and try to slow you down. We have compression, where you're trying to squash or crush something. We have stretching, and stretching is where you're trying to pull or make something longer than it already is. And we have a moment. A moment is a way of making a force bigger by using what's called a lever, which is something a distance away from a pivot. Like a seesaw has a pivoting point. A moment is a way to make that force bigger. Forces generally come in pairs. There will generally be one force in one direction and another force in another direction. And depending on whether they are balanced or unbalanced, you may speed up, slow down, or keep travelling at the same speed. On this car, the forces are balanced. The speed of this car will remain at whatever speed it is at to begin with. So if it's travelling at 0 miles per hour, it'll keep travelling at that speed. If it's travelling at 30 miles per hour, it will keep travelling at 30 miles per hour. The only way to increase its speed is to unbalance these forces. In this car, the forward force is bigger. This means that if it's travelling at say 30 miles per hour, its speed is going to start increasing. If it was stationary, again, it's going to start speeding up. If it's travelling backwards, reversing at any speed, it's going to start slowing down in that situation. So the forward force means that it's going to start moving forward from whatever speed more, it's going to increase its speed in the forward direction, or if it's travelling backwards, it's going to slow down. The final one is this car. This has a bigger backwards force. With this one, if it's stationary, it's going to start moving backwards, and if it's moving forward, it's going to slow down. If it's travelling backwards, it would accelerate backwards to a higher speed as well. Now, moments are a type of force, and we can calculate the moment of a force because it's a turning force that involves an effort or a force being used a specific distance away from a pivot, and it's doing this to try and lift something. If you think of a seesaw, when you sit on one side of the seesaw, you lift something on the other side, and it pivots around the central part of the seesaw. So we have got a moment, if that is what you're looking at. We can calculate moments using this formula. The moment is the force multiplied by the distance. So say you've got a 50 Newton force, 5 meters from a pivot, you are then applying a moment in total in Newton meters of 50 times 5, which is 250 Newton meters. You're increasing the size of your force because it's a certain distance away from that pivot. Thanks very much for watching. Make sure you stay safe, stay alert, stay curious, and subscribe.